Hi guys, so we're going to go over graphing systems of nonlinear equations, and I just want to note a linear equation creates a line. The highest power will always be x to the first power for it to be a line because you've not only seen it as y equals mx plus b, but in algebra 1 you've seen it in standard form like 3x plus 2y equals 1, but again x's highest power is 1. That's how you know it's linear. It creates a line. So just to start off here, y equals mx plus b. B tells us the y-intercept, which is the point on the y-axis. So a y-intercept, if you look here, you have your x and y-axis. The y-intercept is the point on the y-axis. That's a positive 1, so at positive 1, I'm going to color coordinate this. So at positive 1, I'm going to make a point here. And then m is the slope, which is rise over run. And since the slope is 3, and it should be a fraction, so I know what the rise over run is, the fraction form of any whole number is that over 1. So that's a positive 3 over 1. So from my y-intercept, I'm going to go up 3, so 1, 2, 3, and over 1. When it says to run 1, it means always to the right. So even if this 3 were negative, that would tell you that you're going downwards 3. But the run is always to the right. So make a note of that. So from here, 2 points is really all I need to make this line. So from here, I'm just going to plot, well, I can't really draw a line, but you get the idea. So from here, I have my 2 points. There's my linear equation. Now, nonlinear equations means, well, it doesn't create a line. So that would mean the power would be anything but x to the first power. The highest power could be the second or third or so on. I used x to the second power just because, review 303 if you haven't seen this, just because we know anything x to the second power is a parabola. It creates a u. And again, graphing transformations 303, the plus 1, it's not in the parentheses, so that means I'm going to go up 1. So again, I went over this on 303, but x to the second power, the parabola looks like this, 0, 0, 1, 1, negative 1, 1. Since I have that plus 1, that means these 3 points are going to move up 1. So instead of 0, 0, I'm going to move it up 1 and I'll be at 0, 1. Instead of 1, 1, which is right here, 1, 1, I'm going to go up 1 and that'll be at 1, 2. And instead of negative 1, 1, I'm going to go to negative 1, 2. I'm going to go up 1, and that'll be my point. And again, it's a parabola because it's x to the second power. Note the points of intersection here because you do need them to get through 604. So one of those points of intersection was 0, 1. The other one's here. My sketches are a little off, so I'm not even going to tell you what that point is. But notice the points of intersection. So the points where they intersect are the solutions of these two equations. Now, what is an x-intercept? An x-intercept is a point on the x-axis. It's where y equals 0 algebraically. So that means any point on the x-axis is an x-intercept. So starting off, I'm going to take this equation we just got, this linear equation, y equals 3x plus 1. Technically, I don't see any points on the x-axis. Well, right here, actually, for the line. So since I don't really know what point that is, because it's somewhere between 0 and negative 1, I'm going to figure it out algebraically. So again, what you do is you set y to 0. To find an x-intercept, you always set y to 0. And now you're just going to solve for x. So from here, I'll subtract 1 on both sides. And then 0 minus 1 is, sorry guys, I gotta move this over, negative 1 equals 3x. And then afterwards, I need to get x by itself. So x is being multiplied to 3 on this side of the equal sign. So what I can do is divide both sides by 3. And that'll give me negative 1/3. So that's the point on my x-axis. The y is always 0, but that point is negative 1/3 0. Because the y is always 0 in an x-intercept, it's the point on the x-axis. I can already tell you for y equals x squared plus 1, there is no x-intercept. Why? Because look at the parabola in white. There are no points that touch this x-axis. And if you wanted to actually solve it, it wouldn't work. There would be no x-intercept. I'm out of room, but I'll show you on this side here. So if I change the y to 0, I'll get 0 equals x squared plus 1. Again, I'll subtract 1 on both sides. That's gone. 0 minus 1 is negative 1. Negative 1 equals x squared. My goal is to get x by itself. So I want to get rid of this square. How do I get rid of a square? I square root it. Whatever I do to one side, I do to the other. And since I can't square root a negative, that's why there's no x-intercept. So a y-intercept is kind of the same deal, but the other way, it's a point on the y-axis. And to find it, we make x 0. So needless to say, for both the line and the parabola, they both have that point at 0, 1. So that is the y-intercept for both of them. And that's all you need to do. If it's on the graph, you can find it that way. But just to show you algebraically as well, I'm going to take one of these. I'm going to take the linear and just show you algebraically as well. Y equals 3x plus 1. Again, to find the y-intercept, I make x 0. Because let's think about it. Any point on the y-axis, pick any point at all. The x is 0. Because this point right here, this point is 0, 1. The x is always 0 when you're on the y-axis. So, going back to the algebraic part, y equals, using PEMDAS, multiply first, 3 times 0, 0. 0 plus 1 gives me 1. So the y-intercept is 1, and anytime we have a y-intercept, the x is 0. All right, I hope this helps. There will be a second part on piecewise functions.